Day 5, summer school. So what we did to start off the day, we talked about their in-class project. And we did a little review, okay. Mentioned that their trunk should manually be turned on. Turn on IP routing and set up those switch virtual interfaces inside their multi-layered switch. And then the layer 2 switch, you would have an IP address for management. That'd be normal. And then we added some for testing just to see if we could use it for testing our pings and so forth. They have their VLANs, set up and ports put on VLANs. These are router connections, right? And so we need a default out inside the multi-layered switch, and in the router we need a static route pointing back in to find those 10 networks. So their basic configs, trunk, VLAN and port, and then the access router. Be able to access the router. Key things they should have set up, and then they were going to look at their evaluations and see if they had any questions. We took our original diagram and said, what if we want to build redundancy into there, and we connected another layer 2 switch connected to here and to here, maybe these devices connected, maybe here, going out to another router, and some connection out. And we talked about then, how do we control the possibility of a loop, going here, then back to here. Just an example of a loop. You could have a loop here. Somehow or another, you're going to have to block some ports. I did an example here. We're going to have to block some ports and set up a route through this network so that we still have the redundancy, but yet don't have the problem with loops. And that's where we talked about spanning tree protocol. We also talked about some of the reasons we have VLANs to start with. Security, management, performance were 3 of them that the students mentioned. So then we talked about spanning tree. We created the scenario here in which we have, as an example here, a couple multi-layered switch, couple layer 2 switch. We have some connections out. We could do this, maybe this, and this. And so then we talked about the blue VLAN. We can have per VLAN spanning tree incidences. So the blue, if this is the root bridge here, then these are root ports pointing to the root bridge. Okay, so if those are the 3 ways there, and then the ports coming back, designated ports. This can be a designated port, this can be a designated port. And then we have the ports that are blocked for this scenario. I've got them here, here, and here. Those are alternate routes. So then if this route went down, we could use an alternate route to get out. Now, this is what makes this interesting or good. You can have a different VLAN, let's say a VLAN for the students, green, and this could be its root bridge over here. Now the green would go there first. So you could have a root bridge there, a root port going to the root bridge. Maybe this one could use that for the green VLAN. And yeah, maybe here for the green VLAN. And then those other ports would be blocked. Maybe blocked there, where is it? Yeah, maybe there for the green. Now, if this doesn't look confusing, what wouldn't? So anyway, you can have per VLAN, and you can have spanning tree incidences to manage the traffic. So now the green traffic would be going through this one. The red traffic be going through this one. And if ever a link was broke, well, then they all could go the other way. And it would adjust automatically. So, spanning tree protocol, we have protocol data units that are sent all the time, and that's management traffic. But the production traffic, then, that's the traffic then we can't, we want to be able to have redundant links for. And that's the traffic that the people want. They want, they'll use it. So you can, as you get more versed with dealing with networks, you can really see how you can fine-tune your network based on understanding of VLANs, how much traffic you're going to have on your VLANs, and how you would set up spanning tree. Over here we talked about, the access layer getting in, and then this layer which we distribute information through. One last comment. Routing protocols out on the internet, a lot of redundancy in the internet, but they use like a time to live or a hop count, version 4 and 6 of IP, so then that would stop a loop. Once it reached 0, and the package dropped. Then we talked about Ether channel. Link aggregation. We can take physical links and aggregate them to appear as one link using some type of group channel. And there's a couple of protocols you can use. You can use port aggregation protocol, which is a Cisco proprietary, or you can use LACP, link aggregation control protocol, which is a standard. This is the one we used. So you can take some physical links and turn them into one logical connection, called a channel. In our situation, we had a couple trunks in there. They need to be the same speed, all the links, and same setup on each end. There's, all like full duplex, whatever you're doing. But then it's pretty easy to put them in here, and then you can treat that channel as one particular link. And even if a line goes down, it still functions. It can load balance across those lines. It allows for some redundancy in there. In our case, we took these 2 ports. Alright, and then this was just a diagram of our entire layout. We talked about the cloud that I'm managing in here. The red cloud, Dirkville. I manage those routers, and then these are all the students. Right, that's the students' clouds, in which they have a router, a multi-layered switch, finish up this group. They were supposed to get their their ether channel, make sure everybody's ether channel is working, and the basics of their network was working. Each of them are on the same router. Coming off their routers are on the same router. And then I turn those two in. And this group, the same thing. Here we had a default route they need to fix. Here we had a little bit of addressing to fix in Jacob's. Default route out on the multi-layered switch. Zach, I couldn't get into his multi-layer switch because he missed a password. Okay, that is it.